All right, let's talk about Python. It's famous for being so clean, so readable. But just under the surface, there are these little hidden traps, kind of like landmines, just waiting to go off. And believe me, they can trip up anybody, even the pros. So today, we're going to put on our detective hats and expose a few of them.
You know the feeling, right? You're writing some code and it just clicks. It's elegant, it's logical, it's simple. You look at it and you think, yeah, that's perfect. That has to work.
And then you hit run. And what comes out is just weird. Totally not what you expected. It's like the code is playing a trick on you. So that's what we're doing today. We're going to be code detectives, and we're going to solve a few of Python's most common and kind of counterintuitive little mysteries.
Okay, first step on the docket, the case of the treacherous default argument. This one is a real classic, a rite of passage for many Python developers. And it all starts with a function that looks about as harmless as it gets. So check this out. We've got a function called add_to_list. Super simple. You give it an item, and you can also give it a list. If you don't provide a list, no problem. It just creates an empty one for you, adds your item, and hands it back. Seems totally fine. I mean, what could possibly go wrong?
All right, so here's the puzzle for you. What do you think happens if you call this function 2 times in a row without giving it a list either time? You'd expect to get 2 completely separate lists back, right? Each one with just that single item in it. Makes sense.
But that's not what you get. The first time you call it, everything looks normal. But the second time? Whoa. The list suddenly has 2 items in it. It's like it has a memory from the first call. It's not starting with a clean slate. What is going on here?
And here is the smoking gun. In Python, that default argument, that empty list, gets created only once. And that happens when the function is first defined, not every time it's called. Since a list is mutable, meaning you can change it, every single time you call that function without providing your own list, you're messing with the exact same one from the very beginning. It's like everyone's writing on the same whiteboard instead of getting their own.
So, how do we fix this? It's actually a really common pattern in Python. Instead of defaulting to an empty list, which is mutable, we default to none, which is immutable. Then, right inside the function, we just add a little check. Hey, is my list still none? Okay, if it is, now I'll create a brand new, fresh, empty list. And just like that, problem solved. Every call gets its own clean start.
All right, detective, let's move on to our next mystery. And you'll see this one is actually related. I like to call it a list of lies, and it all has to do with something that looks super handy, list multiplication. So imagine you need a grid, for a tic-tac-toe board or something. A quick and dirty way to do it is to take an empty list inside another list and just multiply it by 3. And when you look at it, it seems perfect. You've got what looks like 3 totally separate empty lists. Or do you? Okay, let's poke it and see what happens. We're going to add the number 1 to that very first row at index 0. Now, logically, that should only change the first list in our grid. The other 2 should stay empty. And boom, look at that. We only intended to modify the first list, but the number 1 has mysteriously appeared in all 3 of them. It's like some strange action at a distance has happened. What is this magic?
Well, it's our old friend from the last case, just wearing a different disguise. When you use that multiplication trick, you're not actually creating 3 new independent lists. You're creating 1 list and then making 3 pointers that all point to that exact same spot in memory. So if you change the object using 1 pointer, of course you're going to see that change when you look through the other pointers. They're all looking at the same thing.
All right, time for our final case file of the day. This one's called the loop that skips. And this is a classic trap that gets people all the time when they try to modify a list while they're looping through it. So here's the scene. We've got a simple list with 3 words, foo, bar, baz. We're looping through it, and the code says, if you find the word foo, delete the first item from the list. Seems easy enough. But when we run it, look at the output. It prints foo, as you'd expect, and then it prints baz. What happened to bar? It's gone. The loop just completely skipped right over it. Why? Okay, think of it like this. The for loop is walking down a set of stairs, 1 step at a time. It's on the first step, foo. It does its job and removes that step. But now the whole staircase shifts up. Bar moves into the space where foo was. The loop then says, okay, time for step 2, but step 2 is now baz. It completely stepped over bar because you moved the stairs while it was still walking on them. You're pulling the rug out from under the iterator.
So the golden rule here is don't mess with a list while you're looping over it. It just leads to chaos. The safe move is to loop over a copy of the list. Or even better, a really Pythonic way is to use the enumerate function. It gives you both the index number and the item for each step so you can safely modify the original list without confusing the loop itself.
So we've cracked 3 cases today. What's the common thread here? It's not really about memorizing a bunch of weird rules. It's about shifting your mindset to start, well, thinking in Python. So let's recap the big clues for our detective's handbook. Number 1, mutable defaults are a one-time thing, they're shared. Number 2, multiplying a list doesn't make copies, it makes pointers to the same object. And number 3, do that, I repeat, do not change the size of a list while you're looping through it. But here's the real secret, the key that unlocks all of this. These aren't 3 separate random problems. They're all symptoms of the same core concept, how Python thinks about data. See, in Python, a variable name like mylist isn't the box holding the data. It's just a sticky note that you've slapped onto the box. When you pass things around or multiply them, you're just copying the sticky note, not the whole box. Once that idea really sinks in, all this weird behavior suddenly starts to make perfect sense. And that kind of makes you wonder, doesn't it? If code that looks this simple can hide these kinds of surprises, what other obvious code in your own projects is hiding a secret? Next time something doesn't work the way you expect, don't just get frustrated. Put on that detective hat. Because figuring out the why is what really makes you a better programmer.